Hello everyone, I am Dr. Rajesh and today we will discuss Newton's backward interpolation formula. In the previous lecture we have derived the formula for Newton forward interpolation. Okay, now we will be deriving for Newton backward interpolation. So let us suppose fx be a function that assumes the value f of starting from the backward, f of a nh, f of a plus n minus 1 h, f of a n minus 2 h. This you know is the smallest bracket. Okay, and it will stop at a plus h f of a, and it is assuming the value at x a plus nh, a plus n minus 1 h, a plus n minus 2 h up to a plus h and a. And you know from n to here will be a plus 0 h, n to 0, these are n plus 1 equidistant point. These are n plus 1 equidistant points. Okay, these are n plus 1 equidistant point. This and these were n plus 1 equidistant point. So since we are given n plus 1 values of fx at n plus 1 equidistant point, so therefore we know a result fx could be a polynomial of degree at most n. So let us suppose that let fx be a polynomial of degree n. Of degree n, and it can be written as fx can be written as a naught a1 x minus, earlier it was a, but here we are taking the backward, so we will start with the bottom. At bottom is the a plus nh, fine, plus a2 x minus a plus nh x minus a plus n minus 1 h plus up to so on. It will stop at an, so it will be an x minus a plus nh x minus a plus n minus 1 h up to, and it has to be of degree n, last term has to be of degree n. This is 1, another one 1 1 2, so here could be n terms of x having degree, each having degree 1. So this is degree 1, this is degree 1. So n when goes from n2 and goes on decreasing by 1 and stops at 1, so these are n terms. Okay, so these are n terms, so this is starting from n, decreasing n minus 1, and will stop at 1, then these will be n terms. So here I shall be writing that these are n terms, so it will stop at x minus a plus h, because here coefficient of h is 1, so n to 1, so these are n terms, so and each of degree 1, so this term will be having degree n. So that is how we have written this one. So end point we have to decide at our own, so that it doesn't exceed the degree n. Okay, otherwise we will be in trouble. Fine. Here a0, a1, a2 and an, these are all constant whose values are to be determined. So let me mention here where a0, a1, a2 up to an are constants whose value is to be determined. Done. So we know that at first value is, because let us we are starting from the bottom, we are starting from the backward. Let me write a plus h, a plus 2h up to a plus n minus 1 h, a plus nh. In the forward we started from a, here we started x is equal to a, but in the backward we have the obligation means compulsion. We have the compulsion that we have to start from the backward and we have to start from the bottom, and the bottom the value is a plus nh, because we use the backward interpolation formula when the value that we have to interpolate lies near the end of the table. So this point we must make use of it, that we have to start this from the bottom of the table. So the value that we have to determine of a0 will start with the initial value will in this case will be a plus nh. So at x is equal to a plus nh, we know that f will be f of a plus nh. So now I am going to use this over here. This will be a0, this will become 0, a plus nh will cancel out, this will be 0, so 0 multiplied by anything is 0, this will be 0, 0 multiplied by anything, this will 0, 0, 0, so we are left with a0. So this is the value of a0. Fine, this is the value of a0. Done. Let me name this equation as equation number 1. Fine. Now let me find the value of a1. So for this I will taking the this value. Okay, so it will be, so at x is equal to a plus n minus 1 h, using in 1. So here it will be f of a plus n minus 1 h, f of a plus n minus 1 h is equal to a naught as such, a1, this will be a plus n minus 1 h minus a plus nh. Done. Plus look over here, x when will be placed with a plus n minus 1 h, so this will cancel out, so this term will become 0, this will cancel out, this will become 0, so it will make rest of the terms 0 as well. So last term will be 0, so we are here going to write 0. So this will be f of a plus n minus 1 h is equal to a naught plus a1 plus n minus 1 h minus a plus nh. So I have used the round parenthesis in place of this bar bracket, because I am now going to open and cut whatever is being is possible. So let me write it again. Further simplify a naught plus a1 a plus, so this and this term will combine, so I am going to take h out, n minus 1, this will be minus n, and this will be minus a, this will cancel out, this n will cancel out, so we are left with a naught plus it will be a1 and it will be minus h. Fine. And this implies that f of a plus n minus 1 h is equal to a naught, and a naught we have calculated as f of a plus n plus h, f of a plus nh, f of, I beg your pardon, f of a plus nh, okay, minus it will be h a1. So this implies that so I'm going to take this in the other side and this one over there, so it will become a1 h is equal to f of a plus nh minus f of a plus n minus 1 h. This implies that a1 h. Now see over here, अगर आप यहाँ थोड़ा ध्यान देंगे तो मेरे को बैकवर्ड डेफिन की टर्म्स में, बैकवर्ड ऑपरेटर की टर्म्स में लिखना है, तो बैकवर्ड हम किस से गए, a प्लस एन एच से हम बैकवर्ड गए. सो हम जो बैकवर्ड की टर्म में लिखेंगे, बैकवर्ड का नोटेशन हमें पता है, डेल है एफ ऑफ a प्लस एन एच. ओके, बैकवर्ड हम किस से गए, a प्लस एन एच से गए. अगर मैं इसी चीज़ को लिखना चाहूँ फॉरवर्ड की टर्म में, तो फॉरवर्ड हम किस से गए, हम फॉरवर्ड इससे गए. सो आई विल बी राइटिंग हियर एज डेल्टा एफ ऑफ a प्लस एन माइनस 1 h. तो यहाँ हमें ये ध्यान देना है कि हमें, क्योंकि हमें बैकवर्ड इंटरपोलेशन फॉर्मूला है, तो हमें बैकवर्ड की टर्म्स में पढ़ना है कि हम बैकवर्ड किससे गए. सो वी हैव मूव्ड इनटू बैकवर्ड डायरेक्शन with respect to this one, so it will be del f of a plus nh. So here this will be correct. So in forward terms we have to write this one, this thing, because forward किससे गए, इससे गए, पर हमें इसकी यहाँ जरूरत नहीं है, so I am going to not use it. Okay, so this is the thing. So in fact I am going to rub this one. Okay, so we will be needing this thing. So this implies that a1 is equal to del f of a plus nh divided by h. So I am going to unbox this one also. Done. A naught and a1 we have. Fine. So now at let me write at x is equal to a plus n minus 2 h. Done. So we will be writing, it will be a plus, substituting in 1, using in 1, you will refer the equation number 1. I am going to put it over here, is equal to a naught. Fine. a1 done, a plus n minus 2 h minus a plus nh. Fine. a2, this will be a plus n minus 2 h minus a plus nh. Done. Into a plus n minus 2 h minus a plus n minus 1 h. Done. And rest of the term will become 0. Rest of the term will become 0. You could easily check on the same lines. Okay, so this further implies that f of a plus n minus 2 h is equal to a naught plus a1, and on the same lines this will be written as a plus n minus 2, and this will be n, outside is h, minus a, okay, plus a2. Similarly, this will be a plus n minus 2 minus n, and this will be minus a, into, it will be a plus n minus 2 minus n minus 1. Done. Minus a. Okay, this will cancel out, this will cancel out, this will cancel out. This implies that f of a plus n minus 2 h is equal to a naught plus a1. This will cancel out, so we are left with minus 2h plus a2. This will cancel out, so we are left with, and here outside is h. So now this will be minus 2h minus 2h, fine. And when this is solved, n minus 2 minus n plus 1, and here is h outside also. Done. So this will cancel out, so we are left with the minus h. So this is equal to a naught plus a1 minus 2h plus a2 minus 2h upon minus h. So this further implies that f of a plus n minus 2 h is equal to a naught minus 2h a1 plus 2 h square a2. Done. And we know value of a naught is f of a plus nh minus 2h, and value of a1 is del f of a plus nh upon, this will be h. Done. Plus 2 h square a2. So this will be f of h to h will cancel out, a plus nh minus 2. Using the definition of backward operator, this will be, अब आप यहाँ से बैकवर्ड डायरेक्शन में मूव करेंगे a प्लस एन एच से बैकवर्ड डायरेक्शन, इट विल बी a प्लस n माइनस 1 h. डन. डन. प्लस 2 h square a2. Done. So this further implies that f of a plus n minus 2 h is equal to f of a plus nh minus 2 f of a plus nh plus 2 f of a plus n minus 1 h plus 2 h square a2. Done. So I'm going to, this will be minus f of a plus nh, and going to split this 2 into 1 plus 1. So this will be f of a plus n minus 1 h, f of a plus n minus 1 h plus 2 h square a2. This implies that this will be, okay, so I'm going to take these terms in the left hand side, all these terms, not going to add these two. I am not going to add these two. Fine. So let me transpose the side. It will be f of a plus nh minus f of a plus n minus 1 h, once again minus f of a plus n minus 1 h, and plus f of a plus n minus 2 h, done, is equal to 2 h square a2. So this will further imply that this will be del of f of a plus nh by backward operator. So here I am going to take the minus out so that we could use the definition of backward operator. So I am going to take minus out f of a plus n minus 1 h minus f of a plus n minus 2 h is equal to 2 h square a2. This implies that del f of a प्लस एन एच माइनस, वंस अगेन हम बैकवर्ड डायरेक्शन में जा रहे हैं, किससे, इससे. सो दिस विल बी डेल एफ ऑफ ए प्लस एन माइनस 1 एच इज इक्वल टू 2 एच स्क्वेयर ए टू. अब यहाँ देखिए ये फर्स्ट ऑर्डर का बैकवर्ड ऑपरेटर, सेकंड ऑपरेटर. अब वंस अगेन हम बैकवर्ड डायरेक्शन में जा रहे हैं तो एक और बैकवर्ड ऑपरेटर की डेफिनेशन लग गई. सो फर्स्ट ऑर्डर पहले से है, सो इट विल बी नाउ सेकंड वन. This will be del square f of a plus nh is equal to 2 h square a2. This implies that a2 is equal to del square f of a plus nh divided by 2 h square. So this will be del square f of a plus nh by 2 factorial h square. Okay. Similarly, on the same lines as done in the previous article, we are going to generalize a3 will be when here is 2, 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 here is 2. Similarly for the case 1, we were having here 1, 1, 1. Okay, done. So when here will be 3, so it will be a plus nh divided by 3 factorial h cube, and when it will be an, it will be del n f of a plus nh by n factorial h raised to the power n. Now using all these values in equation 1, using these values in equation 1, what it will be, f of x will be equal to a naught. A naught is f of a plus nh plus a1. A1 is del f of a plus nh divided by h, done, into x minus a plus nh. Now plus it will be a2 del square f of a plus nh by 2 factorial h square into x minus a plus nh, x minus a plus n minus 1 h. Okay, and this will go on up to nth term. In the nth term we have the value an, and here the value of the an will be del n f of a plus nh by n factorial h raised to the power n into x minus a plus nh into x minus a plus n minus 1 h up to x minus a plus h. Okay, so this will be the Newton Gregory interpolation formula. So this formula could also be written in terms of u, like the Newton backward interpolation formula. So we will try to put up into terms of u. So for that we know u is equal to x minus the initial value from the backward is a plus nh, fine, divided by the step is h. Step means a2, a plus h. So difference between two consecutive values is h. Next is a plus 2h, this is again h. So up to a plus nh. So this h is a step. It is also known as interval of differencing. So this is a step. So now I'm not interested in this one, so I'm going to rub this one. Okay, clear one from here. So this implies that x will be uh plus a plus nh. This will be x. This value will be used over here, and a plus nh will be a plus nh. Done. And here instead of this one I am going to use over here. So this implies that this thing will be used. This implies that taking over there, this implies that uh is equal to x minus a plus nh. This implies that x minus a plus nh is equal to uh. Next we have to find the value of x minus a plus n minus 1 h. So for that let me write x minus a plus n minus 1 h. Okay, done. So this can be further written as, if I write it over here, x minus a plus nh minus h. Done. This can be written something like that. This is the whole bracket, these are the brackets, h is multiplied inside. So this can be written x minus a plus nh can be taken together so that we could use this value. So this can be written further as x minus a plus nh minus will be plus, this minus will be plus. So may I put it over here, curly braces. What is this value? uh. So use it over here. uh plus h is equal to u plus 1 h. Similarly, look over here. When in the subtraction it is 1, here is u plus 1. When it will be 2, it will be u plus 2. When it will be n minus 1, it will be u plus n minus 1. So it will be x minus a plus n minus 2. You can easily calculate. So this will be n minus 2 h. This will be u plus 2 h. Okay, done. And similarly, the last value x minus a plus h, a plus h. Okay, instead of generalization I will show you the last value how we will calculate it. This will be x minus a minus h. So what is the value of x? X is this one. So I am going to put it over here. It will be uh plus a plus nh minus a minus h. This a to a will cancel out. Done. So this h will be common. So we are left with u plus n minus 1 h. So this is the this last value. So this is this one. Fine. So I am going to substitute all these values that we have calculated. This one this one, okay, and this one. These values into equation number, you could mark this equation as it is already marked equation number 2. So what will get? You will get, I am going to put the values, it will be f of, it will be, here instead of x I am going to write uh plus a plus nh, done, is equal to a naught. What is a naught in this case? F of a plus nh, fine, plus put the first value, was u h divided by 1 factorial into del of f a plus nh by h into, it will be 1 factorial. Similarly, it will be uh, next value was u plus 1 h, fine, into del square f of a plus nh divided by 2 factorial h square, plus put the next value plus u h, this will be u plus 1 h into u plus 2 h, done, into del cube f of a plus nh by 3 factorial h cube up to the last term will be u plus 1 h into u plus 2 h up to, it will be, the last term will be u plus n minus 1 h into del n f of a plus nh by n factorial h raised to the power n. Look over here, these are n terms starting from 0, because here u plus 0 up to n minus 1, these are n terms. So it will, with every term there is h. So if you are having n such terms, so it will be h raised to the power n, and here is h raised to the power n. So I am going to cancel it out. Done. Similarly here, cube will cancel out, h will cancel out, this square will cancel out, done. So we are left with f of uh plus a plus nh is equal to f of a plus nh plus u by 1 factorial del of f of a plus nh plus u plus 1 by 2 factorial del square f of a plus nh plus u plus 1 u plus 2 divided by 3 factorial del cube f of a plus nh by, it will be 1 plus u plus 1 u plus 2 u plus up to n minus 1 divided by n factorial into del n f of a plus nh by 1. Okay, there is nothing in the denominator, we have adjusted the n factorial over here. So this is the Newton Gregory backward interpolation formula in terms of u. So this formula is used when we have to calculate the interpolated value which is near to the end of the table. So we will be using this formula. So that's all I have from this lecture, and I hope you will be able to understand the basic concept behind the proof. And So if you have liked the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye, take care, bye bye, and see you soon. Thank you very much. Thank you.